Hey everybody, Geology 351 from the field, up in First Creek area, north of Ellensburg, high up above First Creek, and looking for some rhyolite exposures. I'm newly interested in the rhyolite of the Teanaway Formation. Today, I'm with Andrew Sadowski from the Washington Geological Survey, and we're up here on top looking down at First Creek, looking south through the Green Canyon Notch, and we found some rhyolite. Good looking stuff. Let me show what we found.
I'd say so. I've seen enough hydrothermal alteration here to suspect that there could be something interesting going on. Like, here, I just saw that. Looks like some quartz bands and veinlets, maybe in this altered material that we're walking over. Because where we were up at the top there was not as altered as what we're going to see down here. So if we were at rhyolite and vitrophyre up there, we're now going to be at like altered rhyolite down here.
Now viewers, I'm glad you're with us today. Please keep in mind, it's kind of gutsy to film as you first visit a place.
Yeah.
You can pretty easily come off like a buffoon. Now I got no problem doing that on a regular basis, but Andrew, you know, his reputation's on the line here, for goodness sake. Not really, but...
Oh yeah.
You know,
no pressure.
Be easy on us now. Oh my God, I know you're going down there.
Yeah.
This is what I was hoping Teanaway rhyolite would look like. It's a freaking rhyolite, man. It's pink.
Yeah. On that rock there in particular, it looks like a lot of oxidation. So you're kind of iron oxides, including goethite, maybe some limonite and some hematite there. Are
you saying the pink is?
Yeah, the pink could be kind of an after effect, but it could also not be.
I'll temper my enthusiasm.
I mean, it's still really interesting, and it's still may be part of it, but it could also be tinted with, you know, that other oxidation story.
The voice of reason, Andrew Sadowski.
So if we kind of walk down this little bit and then turn around there,
sure, good.
See some nice stuff.
Take the scenic route. Oh, I could have done the Rainier shot here, man. One more time, just for bearings here. If you're good with Google Maps and things, you can maybe find our little ridge right now, because I'm giving you a few landmarks. Green Canyon Notch looking south. First Creek is flowing west down towards US 97, which is, and what that flat kind of bare area is Swak Prairie. Mount Rainier in the distance, Lookout Mountain. Maybe I can zoom on Lookout Mountain. So Cle Elum, Washington is at the base of Lookout. Let me zoom for you if I can. Lookout Mountain, which is the end of the line for the Columbia River basalts. Cle Elum down low. And then again, circling around, we're confident this is Teanaway basalt dipping, 20 to 30 degrees?
30 something, 32, 33.
32 degrees to the south, generally-ish, and Liberty and Rob's Gold Mine is on the other side. That's our bearings. All right, let's try to look at this outcrop. What?
So it looks a little less like rhyolite that we've been seeing on the walk down here, just because it looks a little more
it's screwed up though, isn't it? It's not the...
Screwed up is a good term, yeah. Like I really feel that deep. That's what I say to myself when I first come to something like this.
So I say screwed up, and what are some other words you'd use? This is definitely hydrothermally altered?
I'd say hydrothermally altered.
And what are you seeing here to give you that impression? Why isn't this the original look of this lava when it came out of the ground?
It's far lighter than a lot of the other kind of rhyolites that we see in other places. It also kind of has this, I don't know how well it's captured in the video because the light's kind of patchy here. I mean, if we came here maybe a couple hours later, the golden hour would be upon us and we could see some of the textures more. But this kind of blotchy, yellowish bit right there.
Let me come totally in the shade over here. Maybe this will work better for them and maybe for you as well.
And this is a kind of a weathered surface. This side looks a little fresher, but you can see kind of a little variation in the blocks here. Now maybe it's an argument. This is again my first time being here too. So like it might not be hydrothermally altered. Instead, maybe it's just pretty thoroughly weathered. And what we're seeing is kind of the weathered surfaces here and there. Things like thin sections and geochemistry might help us elucidate whether or not there is like a secondary alteration process acting upon here.
So I was excited right over there because it was such a beautiful pink, and to me that looked like super fresh and pure, and this is like was pink but has been...
Yeah, like here's like a little bit of that pinkness that you keyed in on, which I didn't mean to kind of, you know, poo-poo it, but like I think there are a lot of things happening on that.
Sure.
Just like there's a lot of things happening on the surfaces we're
well,
looking at here.
so right below we're back to that good-looking pink, at least to my eye, and maybe the camera will pick it up as well.
Yeah, it's a beautiful piece.
So you're watching and you're going, okay, I don't get why you're so excited about the rhyolite. Well, from my point of view, and then Andrew can weigh in, I guess, as well, but from my point of view, I'll flip you around. From my point of view, in the last 5 years, I've been teaching about the Teanaway basalt, the feeder dikes, and the cracks forming in the swamp. And suddenly we have this volcanic event 49 million years ago, and we have this basalt coming up these feeder dikes and burying this swamp. And that's the end of my Teanaway story to this point. I've focused on the basalts of the Teanaway. Well, this rhyolite that Andrew and I are looking at this afternoon is clearly part of the Teanaway formation. But one of my goals this spring, is to ask some pretty basic questions. Is the rhyolite of the Teanaway formation younger than the Teanaway basalt story? Or vice versa, number one. Number two, is the rhyolite, well, where's the rhyolite coming from? Did it come out of the ground here? Is this ash flow tuff that got blown into this area from a distant source? Is this a Yellowstone hotspot story? It can't be. It's way too old. Even if this rhyolite is younger than 49 million year old Teanaway basalt, it still has to be, well, what? How young could this be? We don't even know that relationship. Does this rhyolite sit definitely below the Roslyn formation? We have good dates on the Roslyn now. We think it's below the Roslyn,
less
therefore...
than 45, more than 16, pretty poorly constrained.
Right. So there's embarrassingly simple answers to be yearning for. And as usual, some of the answers have already been figured out, and it's just ignorance on my part. And sometimes it's enlisting guys like this to expand his map area and get up here and start doing some stuff with this really interesting area. Back to Andrew. What is your routine when you're at an outcrop like this? Let's say we weren't here and you were just doing your thing. Would you collect a sample every time?
Yeah, I generally over-collect samples. I'd rather have more samples that I don't need than samples that I wish I collected and have to go back out for later. So the routine would be first kind of locate myself on the map, start the log in my field book, you know, what station number is it, where is it, what's the exposure like, it's an outcrop, and you know, what are other features about it, what's its color. There's actually a nice fault surface here.
There is?
Yeah, that's what all these sub-horizontal slicks are.
Show us those.
So I don't know if you can see this well because of the
light's
shadows,
pretty good to see them actually,
but you can kind of see that there's this grain to the outcrop here that's kind of striking towards Nick. And I mean, one way to look at this is like, all right, well, this tells us one of two directions that the fault plane could have moved. Other kinds of subtle things, if you look at these kind of rough facets here, if you imagine the part that would have broken off here, that would have gone that way because it couldn't have gone back into this fault. So we can kind of already see that there's a maybe strike slip component that's being offset in a right lateral sense of slip. Other things that I'm seeing here are possibly these small fractures that are another type of kinematic indicator that lets us know that something moved here, such as a Riedel shear. And this is maybe a more reliable indicator of the sense of slip. And again, I've just have started looking at this, so it's...
But you're seeing Slicken sides.
I'm Slicken. The main feature of this surface that kind of defines it as a fault surface is the Slicken lines and Slicken slides right here. So that's these like really kind of smooth texture, sometimes called pseudo-tachyllite. It isn't super shiny, but it is slightly polished. So I'd kind of get out my Brunton compass, measure that, measure the strike and the dip, which is an orientation of a plane in space.
Would you mind showing us how you would measure a Slicken side or a Slicken surface?
I'll show you how to measure the plane. Measuring the Slicken lines will take a little longer because I'll have to get out a few other accoutrements. But I'll take my field book, I'll slap it up against the outcrop here, get it so it's representative of the plane. I'll put my compass up against here. I'll get the bubble level here. There's a circle bubble level in there. And once that's level, I can read off the strike from the compass, which last time I did it was about 212.
Oh, 212. Oh my God, 212? Are you serious?
That's just the strike.
Okay.
And it's still, I picked a good spot because I'm getting the same reading here. So that's part of it. And then I flip the compass another way and I measure the dip. So how much this is inclined. This is almost vertical, but I play with this little inclinometer at another bubble level in here. And once I get that kind of leveled, I can read it off from another dial in here. It's giving me about 72 degrees dipping to the north. So 212, 72 north with subhorizontal slicks in a right lateral kind of sense of offset is a pretty good characterization of this fault here, and might be telling us about something that was happening a very long time ago, say Eocene or Oligocene times.
So you had your yellow field book up against that surface, and that was the orientation of the fault plane when the fault was active and making earthquakes here.
Correct.
Got it. And is there a fault mapped right through here?
On the 100K map of Tabor and others, no. So this is really fascinating to me because there's been a lot of talk, at least in my division and group, about some of these older structures having an impact on some of the younger structures that are maybe active in the valley. And maybe these younger structures are taking advantage of there being pre-existing older structures here.
Yeah,
So
yeah.
The stress that is being acted upon the valley is getting taken up on different places. So this is pretty cool to me because this helps me connect the older bedrock to the younger bedrock.
Ah, man.
Would make a detailed rock description, kind of begin to write out not just my observations but my interpretations of how this might fit into the larger map area that I'm looking at. So it's not just all measuring things. It's great and fun to use the Brunton. I still do. There's other ways to measure surfaces. There's a lot of apps on the phone now that can do about the same thing.
You got everything you ever want on your person right now, man. You're pulling on an iPad with LiDAR.
That's in the back here.
I just cued him now.
There's the tablet that I've been working on.
You want to? I won't get too close. You want to show us where we are?
Yeah. So we're on this blue dot right there, and if I zoom out even farther.
Oh, come on. Let me see if I can zoom.
Kittitas Valley is down here. Yakima River is coming down through here. So we're up. Way up here.
I guess we're in too much sun. I don't know if
Liberty's
I can see
over there.
very well.
Yeah, it might not work out. I need to get in the shade. But well, gotta come prepared.
Well, God, you are. You are. I mean, the Teanaway basalts, I'm thinking the most simply, 49 million years ago, they come out of the feeder dikes and they're sitting essentially horizontally, and they're just not sure how much of central Washington they were burying essentially, but then they get tipped and dipped.
Yep.
Actually, we don't know when that is, do we? Let me back it up.
Okay.
So I see a giant Oreo cookie here. I see the Teanaway basalt, which is 49 million years old. That's one of the wafers of the Oreo cookie. We're looking west. In the snow is the Columbia River basalt, 16. So 49 million year old basalt, 16 million year old basalt. That's the other chocolate wafer of the Oreo cookie. Zoom out, zoom out. Oh, I can't anymore. So we're looking down the cream. We're looking down the guts of the middle of the Oreo cookie. And I guess I don't know right now. Maybe you have a thought. when did this fold? Is it that the Teanaway is dipping steeper than the CRBs generally?
That's right. Generally, yeah.
And that's one vote to say that there was some folding of the Teanaway before we started folding the CRBs. I don't really know the answer to that.
Yeah, this is I mean, the last publication I put out kind of put in areas for recommended research and future research, and it was kind of this time period we're talking about right now, where the regional tectonics right here, northern Kittitas Valley, we're kind of pretty far away from the Yakima Fold and Thrust Belt, like we're entire valley and several different types of stratigraphy away. There's something happening that's a little different at this point in time. So this like pre-16 MA, because we're standing in pre-16 million years ago rocks, but then post, Eocene time. So, we've got Eocene, Oligocene, Miocene. What's happening in that window locally? Ray Wells and McCaffrey, and I think, I forget what date that paper was, maybe 2013, said it's like, okay, there's been clockwise rotation since about 16 MA. So, that's kind of basin driven by the basin and range you've talked about in your videos. But kind of right before that, I don't know what was happening. And it's like we're not talking about the deformation of the SWOC. We're kind of talking about what's happening after that even, because the SWOC is well exposed, but the stuff we're standing in doesn't quite have the attention given to it that we need. So yeah, we're scratching our heads.
We're scratching our heads. We need to give more love and attention to the cream filling in the Oreo cookie. Thanks. Want to do anything else here? Or you want to move on?
I don't know. It's up to you. What is?
I want to find that first vitrophyr piece, man. That was
pretty cool. You still recording?
Maybe.
All right. I
there's a trick that I've learned through the years. Like when you interview somebody out in the field or whatever for our TV show, the person's real stiff and like, oh God, I don't want to make a mistake and whatever. And the camera guy I'm with usually likes, okay, well, let me turn this camera off and then we'll loosen you up. And he doesn't turn it off, of course.
Yeah, right.
So then the guy's like, or the gal speaking so freely, and that's usually the stuff we keep. It's kind of like a dirty trick. Kind of like right now, actually.
Hollywood.
Oh, see now, well, there's your blotching.
Yeah.
But there's much more pink than we had.
Yeah, I think some of that's hematite.
You do.
I do. I mean, like, it's hard when it's so close and when it's in rhyolite. Kind of telling the difference between that is a keenness of the eye that I've developed, not as well as some of my colleagues in the economic geology fields.
Oh, my Lord. Well, it ain't the salt, man. I don't care if we alter it a little bit. It's still silica rich, so I want to know the story. And if there's a vitrophyr, we have to have a thick deposit then, right? Or even a vitrophyr implies airfall tough?
Not always.
Is there a vitrophyr at a base of a simple lava dome?
I mean, mapping in some of the parts in Nevada where I was, I regularly encountered vitrophyrs under like some ignimbrites, but it wasn't really, I don't know if they'd happen under flows.
That's what I'm thinking. That's the only place I've seen them, underneath the ash flow tuff. Like it's instantaneous pile up, and then you've got so much heat that you just
weld and
weld the base of it.
Yeah, that's something I forgot to say. The pumices and those fiamme are not just compressed, but they're welded.
Yeah, you can't pick them out. I mean, they're solid glass or
really fragile, but not fiamme. It's welded tough usually. TUFF.
Okay, now my mind is racing. If we agree this is a vitrophyr up here, is that a strong vote for this being a distal deposit of some high energy silica event? I'm trying not to say supervolcano or caldera, but I mean,
it could be really local, like just, okay, the rhyolite kind of popped out, and with that eruption came some tuff and ash. I think like ascribing much more catastrophic things or events to where we don't have large deposits is tenuous. So all the other kinds of clay minerals, montmorillonite, etc., etc. And oh my gosh, just propylytization or propylytic alteration just means it's been chloratized, so the rocks will look a little greener. Not green like, you know, your copper deposits,
Right.
and not green like, you know, malachite and stuff like that.
Yeah.
But, you know, there'll be like a hint of green there, and if you pop that under a microscope, you'll see more chlorite minerals, or minerals that contain chlorite. So, going back to what you said, if there was, are we near source or far source? Like, I don't know, like hydrothermal alteration doesn't necessarily always extend in a lot of different directions unless you have a bigger system, and I think we're just still trying to understand that.
Well, we definitely are, but I guess I just never thought of. I just assumed the rhyolite here would be at the source. I don't know why.
I think the rhyolite is. I think the ash fall is maybe nearby, but not necessarily distal. It's tough because there's not a lot of literature here, and like this is
Right.
let's
yeah.
say day one of the beginning of understanding like a very long-lived story.
Plus, we're at the edge of the CRBs. They're right over there, by the way. So, like, is most of this, if this rhyolite exposure is part of a much larger story, is it likely that most of it's into the Columbia River salts? Oh, hey,
Got a partner.
you're not happy right now.
Nope. The tick is gone.
Those ticks love you,
They
man.
love me. I don't know.
Why
what
don't
it
they
is.
love me? What is it about you?
I don't know. Popular.
They can sense intelligence.
Not the kind of.
This probably too early, like an embarrassingly early stage. Oh, he's got it.
That's what you were looking for.
This is what I was looking for. I picked this up and I said, I don't know, Andrew, this looks like vitrophyr to me. He says, I think I agree.
Oh yes.
The vitrophyr, as I recall it from 35 years ago in my master's thesis, is a glassy zone from a very high silica supervolcano event, and the vitrophyr forms only at the base of a very thick ash flow or ash fall or both deposit. Like at the base of the Bishop Tuff, there's a vitrophyr. And if you go to Bishop, California, and you find the Bishop Tuff from the Long Valley Caldera, and you hike to the bottom of, what is it, Owens River Gorge, I guess, and you start at the bottom of that unit, it's black, glassy stuff, kind of like what I was just looking at.
Like this. I don't know if the
And
camera
then-
picks up on the shine.
And then you walk up and up and up and up the road. I'm talking about Eastern California now, and you get to the top of the Bishop Tuff, and it's frothy, light tan. It looks like foam at the top of that single supervolcano event. And I don't think it's outrageous to ask here, if we have a bunch of rhyolite from the Teanaway Formation time, and we have a vitrophyr, and we have flattened pumice, fiame in other words, we visited one outcrop, but if there's enough of these rhyolite outcrops visited, is there a larger story to be told?
Yeah.
Stay tuned.